Okay, now's the time for Wayne's World. Totally amazing, excellent discovery.
All right, so this is like a two-person Coy chamber. It's flexible. As you can see, it's designed to do anaerobic work for microbiology, basically. So the way that it functions, I'll show you really quick. If you look inside, so the first thing you can see probably is there's a sensor there. So that sensor is just indicating to you the oxygen concentration on the left and the hydrogen concentration on the right. As you can see at the moment, they're both 0, which is actually problematic. So oxygen should be 0, that means that we're anaerobic, but hydrogen needs to be somewhere around 1 to 2%. And the reason that it needs to be 1 to 2% is that the mechanism by which the chamber removes oxygen is by reacting hydrogen with oxygen over a catalyst, and the catalyst is contained within these they're called cat packs or cat stacks, as you can see here. So this is basically just a big box that has a fan in it. There's a fan on the end here, as you can kind of see with the little grate. And this fan just continuously cycles air in the chamber through this screen on the front, as you can hopefully see there. Inside that screen there's catalyst, and this catalyst takes hydrogen and oxygen, reacts them together to form water. And so there's also desiccant inside of that stack there, and that desiccant then absorbs the water. And so this is the mechanism by which you continuously remove oxygen. Oxygen not only diffuses through the walls of the chamber, as you can see they're made of plastic, but also comes in through the door, which is over here. And you can probably see there's another catalyst pack back there. So there's 2, it's a fairly large chamber, so you need 2 to keep the thing fairly anaerobic. Okay, so the door, this is called an airlock. It's got 2 doors, as you can see, basically so that you can make the environment inside anaerobic, and then open the inside door to take things in and out, and then close the inside door before opening the outside door so you don't let air in all the time to keep things relatively anaerobic. Okay, so as I said, we have this problem that the hydrogen concentration is 0 at the moment. We need to get that back up to about 1. And as you can see, if you look at our airlock again, the door is currently in aerobic state. That means that this outside door has been opened. So it says aerobic because there's essentially air in there at the moment. But before we can reload the chamber, the gas cylinder is empty. So I'll show you the cylinders. So there's copper line that runs from the back of the anaerobic chamber airlock all the way over to the gas cylinders, which are located here. There's 2 types of cylinders. This one is nitrogen. It's ultra high purity, so it has relatively trace amounts of oxygen in it. This one is a mixture of hydrogen and nitrogen, so it's 5% hydrogen, and the balance is then nitrogen. So it's not flammable at that point, but there's still some differences in terms of like the regulator because you're working with hydrogen. Okay, so if you can see up here, our hydrogen cylinder, although it's open, is currently empty. So we need to change the cylinder before we can use it. So we're going to do that real quick. Okay. Okay, so tighten that. So this closes the cylinder itself. I'm now letting the pressure off of the regulator. Okay, so this is loose, which means that there's not going to be any gas flowing through here anymore. But you see the pressure is still high, so you can relieve this little remaining bits of pressure by coming over here. I'll explain what I'm doing with this thing after a bit. Basically, you can manually operate the piece of equipment, but I'll explain that later. Okay, so we've now removed any leftover gases inside the regulator. We can shut the regulator off with this little valve here, and I have to get a wrench. A cylinder that contains hydrogen, so it's backwards.
Oh,
so
man.
Normally it's righty tighty lefty loosey, so always just remember there's the opposite for these guys. So I'm turning it to the right currently to take it off. It should be fairly straightforward. If you can't get it off turning left, then try the other way, I guess. But the nitrogen tank, which is here, is the conventional lefty loosey. In this case, it's Opposite. Okay, so drop that. Okay, so before moving the cylinder, you want to make sure to put the little cap on. Now I always monitor the gas concentrations, or excuse me, the remaining gas volumes here. So this one's fairly full. It's at 2,000 psi still. I think it comes around 2,500. When this gets down lower to maybe like 500, I'll order a new one. So for the hydrogen-nitrogen mix, I already have a new one sitting here. So all we need to do is move it a little bit closer. Always want to make sure your cylinders are attached to the wall if you're not moving them. Carefully move cylinders. Okay, so you can show this too. If you're ever needing to know what's in there, you can always look on the label. It should say here. It gives you nice information in terms of the composition. Here is also just a general type of cylinder, so it's 5% hydrogen. And then lastly, there's also this certificate of analysis that Praxair provides, which let's see. You can't see it because it's all folded up, but in there it will tell you not only the requested concentration, but the actual concentration is measured by, I think, a GC in this case. So. Okay, so get it strapped to the wall before you do anything. So a lot of times these little caps will come off. If not, there's a tool in the lab. Usually it's in 232 by the fume hood. But basically that tool has a little hook on it that you hook to the little hole and you can open them if they don't come off. Alright, so there's this little thermoplastic thingy here you can take off. So again, you have to go left to get it on. I can show you this too really quick. The regulator also has an indication that this can be used for hydrogen. So if there's any question, you can always check or look up the type of regulator, which is also listed on there, just to make sure. Okay, so get it as tight as you can. Make sure it's on correctly with your fingers, and then turn it more, get it tight. So don't go crazy with these and tighten them too much. The nitrogen tank you have to tighten a little bit more because it's a little bit more difficult to get them to seal. Okay, so we can then slowly open the gas cylinder, and you see that the pressure is up near 2,000 psi. At this point, it's important to check to see if there's any leaks, mostly just by listening, but I don't hear anything. And then tomorrow, or even later this afternoon, I'll check to see if the pressure is still high. If it's going down rapidly, that means that we're leaking somewhere, which is obviously problematic. Okay, so we can open that a little bit more. We can also then turn our regulator, turn it on. Okay, so you see the pressure should be rising. And we're going to put it up to 30. As you can see, there's a little indicator here that says that the gas mix should be less than or equal to 30 psi. That's just indicated by the company themselves, so I leave it at that. The nitrogen cylinder, as you can see, is listed here at less than or equal to 50 psi. The actual reading at the moment is a little above 50, but when the gas is flowing, it'll drop down. Okay, so that's how you change the cylinder. The same thing would apply to the nitrogen tank.
Just had an ambulance right there.
Huh?
Just had a fall. I got it on video.
What's that?
That's the vice hitting the water. I just got it.
Okay, so we're back here after a short break, commercial break, I suppose. And yeah, so we need to basically refill the chamber at this point because it's still at 0. We just changed the cylinder. So what we're looking at now is the operating screen here. You can't really see anything other than this P9. Right, yes. So this actually says ready, and it has 0.0 inches of mercury. The screen is a little broken, so you can't read that very well. All it means is that it's ready to operate the program 9, so that's P9. You can run P1 through 10, but right now it's set for 9. And the current pressure inside of this is 0 inches of mercury, so it's atmospheric. It will go up, but it's actually pulling a vacuum on the inside, so I'll show you how that works. Okay, so P9 is just a preset program. That's what we use all the time. It pulls vacuum once, and then it fills with nitrogen. It pulls a vacuum again, it fills with nitrogen again, and it pulls a vacuum again, and it fills with the nitrogen-hydrogen mix, at which point it will say it's anaerobic, and we can then open the inside door. Okay, so we need to do that before we open this so we don't get a bunch of air into the chamber. So, if it's ready, P9, we can just press start. It's currently pulling a vacuum. You can see that it says vacuum. The pressure will decrease. It says it's increasing, but all the way up to 20 inches of mercury, essentially. You can't really see it. If you look, you might be able to come down here like this.
Nothing with the camera.
Okay, anyway, that doesn't matter. Okay, so it now says purge gas cycle. You can't read it, so it's not all that interesting. Okay, so it'll then bring the pressure back down to near atmospheric by putting in our purge gas, which is just nitrogen. And pull the vacuum again. I mentioned that the pressure was a little above 50 before, so now the gas is actually flowing. The pressure is exactly 50, so you can just maintain it at that. This is also a good way to see which gas is flowing. You can watch the gauge change. So if you keep watching, it should jump here in just a moment. So the pressure is a little bit higher now. So that just indicates which one's going. So then you can come over here. Because we just changed this cylinder, the pressure is a little bit different than where it started. We'll see what happens when it actually starts to flow here. Give me just a minute. Alright, we can turn this up just a bit. Okay, so that's now going to fill the chamber, which you can come back over here. At this point now it says gas mix, so there's gas in there somewhere, and then mix here, which helps you to know which one it's actually doing there. So this is the final cycle. At the end of the cycle it will beep once it reaches no vacuum anymore. Okay, so beeped, and now you can see this says anaerobic. So before it said aerobic, now it's anaerobic, meaning that it's relatively oxygen-free inside of there. So at this point, you obviously don't want to open the outer door, or else you have to do the whole thing over again. But we can open the inner door, so carefully, let's slip our hand in here. You can open the door just like that. And we're going to leave that door open because we're actually going to refill the chamber to get the hydrogen concentration back up. Okay, so I have to teach you how to use manual mode now, which is actually fairly easy. So you can come back over to this screen. So previously we just used the start button to start the process there to make the chamber airlock anaerobic. Now we're going to manually adjust or pull vacuum and insert gas. So in order to do that, we press menu. Now it gives you like 4 options here. You can't really see these ones, but that's okay because all you need is this one, which says start will take you to manual mode, or M mode. So press start. Now it says manual mode, up equals vacuum, down equals purge gas, start equals mix, and menu equals exit. So at this point, if we press menu, it gets us back to P9. So we'll have to do that again. It's going to go through our little description again. So now at this point, we can do whatever we want. So we can press up to pull a vacuum. We can push down to do the purge gas, or press start to do the gas mix. So an example, that's purge gas. It says purge gas. This gas mix, and it says gas mix, and then our vacuum. So we're actually going to leave the inside door open, and we're going to pull a vacuum. What that's going to do is pull the contents of the chamber out into the room, and in doing so, we can empty the chamber and then refill it. So we'll do that. Okay, so we've been pulling vacuum now for a few minutes, I guess, and evacuating the contents of the chamber. I didn't mention before, but I wanted to make a note that the chamber contents are literally just evacuated right out the back of the airlock here. And so what that ends up doing in this room is it sort of accumulates right here in the corner. And I'm always a little bit nervous about the fact that a bunch of gas that doesn't have any oxygen in it is coming out here. So I usually open this window right here to get some fresh air as I'm standing here so I don't pass out. I don't know how much of a concern it really is, but I guess I'm just nervous. Okay, so if you look at the chamber, you can see at this point it's actually quite sucked in. It's not puffed up like it was before. And this time I did actually pull a pretty significant vacuum here, so I really removed a good portion of the contents. And the reason I did that is because the hydrogen concentration is so low. If it were, say, at 0.8 at the moment or something, you wouldn't have to pull nearly as much of the gases out. Okay, so now that we've got a vacuum pulled on it, we can fill it back up with mixed gas. So if you recall, the up button is for the vacuum, the down button is for the purge gas, and the start button is for the mixed gas. So we're going to just push start, and as you can see what it's doing, it just says gas mix, and it's simply going to pump the chamber full of gas. Okay, so we just finished filling the chamber with the gas mix. As you can see, it's now puffed back up, and we are at a hydrogen concentration of 1.6%, which is sufficient for our needs at this point. So now it's fine, we can just leave it. Before we leave it though, we should shut this door just to, have 2 barriers to the outside, just in case somebody were to open the outside door. And the other thing is that we need to change it back to the regular mode. So it's currently in manual mode still. So if we press the enter menu button, we can get back to our P9 mode, which is our pre-programmed cycle for purging the airlock. The airlock is still anaerobic at this point, so if you wanted to, you could take something out of the chamber, put it in the airlock, and then take it outside. Or if you want to put something in, you're going to have to open this door, and it's going to become aerobic at that point before you put it inside. So I think it's fairly straightforward about how to get something in, but I just mentioned really quick. If you did want to put something inside at the moment, you want to open this door. You'll then place the materials inside. You'll close this door, make sure that it's latched, and then you'll press start to run the 3 vacuum cycles and then the 3 gas purge cycles, at which point it will beep and say it's anaerobic. When it's anaerobic, then you can, with the outside door closed, you can open the inside door, take the stuff into the chamber and then place them inside, and then again close the inside door. A few things to mention are that so it does pull a vacuum of 20 inches of mercury, which is fairly significant. So for typical things that are sealed, like media bottles and stuff like that, I will loosen the cap just to allow gas to exchange. It probably helps to remove oxygen as well. If you were to ever bring warm media in here, so let's say you took something out of the autoclave and it was still decently warm, you need to remember that under low pressure inside of a vacuum it may have a tendency to boil, so don't do that because it's bad, and I know based on experience, so don't put it inside. And other than that, The only other thing to mention is that right now it's sort of a confusing time because, as you can see, we've come back to the P9 screen. Can you see the screen? There you go. And we know that it's anaerobic because we were just working with it, but at this point it doesn't actually tell us that. So if somebody new were to come in, they would have really no idea whether it's anaerobic or not. So my philosophy is just always assume that it's aerobic, and if you want to open the inside door, you need to run the cycle, unless you know for sure that it isn't. For example, we know now that for sure it is anaerobic. But if somebody new were to come in, they should assume that it's always aerobic so that they don't pump the chamber full of oxygen, because that could be bad. Okay, other than that, I think we're okay.
What are the other programs?
If anytime there's a problem, so let's say for example you put media in there that's hot and you're running the cycle and it started to boil, you want to immediately stop things and get the chamber open. So in order to stop a cycle in progress, the only way I know how to do it at least is to shut it off and turn it back on. That will immediately stop the vacuum or the gas purge, whatever it is, and at that point then you can go back to the manual mode and adjust things accordingly. So if you have a partial vacuum pulled, let's say 10 inches of mercury, you're going to have to shut the thing off, turn it back on, go to manual mode, and then purge it with the purge gas in order to get the door open. Because even a vacuum of a few inches of mercury on this thing won't allow you to open the door. So the door will be essentially shut. You won't be able to move it at all, even if you open the latch. So yeah, that's good. Other than that, I think that other things we can deal with in the future.